Good morning, students. Today we start with the second main of part D. That is, in the second volume, part D 5. So this is also for 5 marks, right? So the first question: deduce the relation between N, U, V, and R. So here N is the refractive index, U is the object distance, V is the image distance, and R is the radius of curvature. So in other form, they also ask for deduce the relation for the spherical surface. So spherical surface on the ಕೇಳಿದ್ರೆ ಅಥವಾ n relation between n, u, v and r ಅಂತ ಕೇಳಿದ್ರೆ both are same. So here we are going to derive the relation between the variables n, u, v and r. So that is by considering the spherical surface. So consider one spherical surface which separates the two medium, so which having the refractive index n1 and the spherical surface having the refractive index n2. So one spherical surface considered ಮಾಡ್ತಾ ಇದೀವಿ. So that spherical surface having the refractive index n2 and n1 is the refractive index of the air medium or vacuum, right? So now first step is to draw the principal axis. So next end ಮಾಡಬೇಕು, draw ಮಾಡ್ಕೋಬೇಕು, right? So next consider object from the pole of the center of that is from the pole of the spherical surface, right? So consider object on the principal axis. So the object considered ಮಾಡ್ತಾ ಇದೀವಿ ಇಲ್ಲಿ ಅಂದ್ರೆ on the principal axis, right? So this is the principal axis. So on the principal axis at a distance u from the pole of the spherical refracting surface. So this is the pole, that is the center of the refracting surface, right? So next we need to consider the rays. So here we are going to use the ray diagram. So ray diagram use ಮಾಡ್ತಿರೋದ್ರಿಂದ considering the two rays. So one is like this and another one is along the principal axis. So we are considering two rays, right? So these two rays are the incident rays. So after incident on the spherical refracting surface, so surface mele incident agtide andre, so those rays will refract it, right? So these two rays will meet at a point that is what image. So that is at a distance v again from the pole, right? So next draw the normal at the point of incidence. So here we taken m is the point of incidence. So at this point if we draw the normal, so that normal is always passes through the center of curvature. So now ಯಾವುದಾದರೂ ಒಂದು spherical refracting surface ಗೆ normal draw ಮಾಡಿದ್ರೆ, so that normal is always passes through the center of curvature, right? So here we taken C, where C is the center of curvature, right? So the incident ray which makes an angle with the normal, so that angle we call as angle of incidence. So that we taken I. So where I is the angle of incidence. So the refracted ray makes an angle with the normal, so that angle we taken as angle of refraction, that is R, right? So these two kuda diagramally mention agire, right? So next draw the perpendicular line from the point of incidence to the principal axis. So we taken that is M, right? So one perpendicular line na draw ಮಾಡ್ಕೊಳ್ತಾ ಇದೀವಿ from the point of incidence, right? So this is about the that is basic information about the relation between N, U, V and R, right? So that is question number 1. Relation between N, U, V and R, right? So information irbekanದ್ರೆ U, that is object distance, V distance, right? So refractive index n1 for the first medium and and N2 is the second medium, that is for the refracting surface. So another medium, so that medium refractive index N2 irutte, right? So radius of curvature, that is from the pole. So pole in the measure model, that is the distance PC is the radius of curvature. So ಯಾವುದಾದ್ರೂ ಒಂದು normal na draw ಮಾಡಿದ್ರೆ, so that normal at any point on the refractive surface, if you draw the normal, so that normal is always passes through the center of curvature, right? So distances are measured from the pole. So from the pole to the center of curvature, we take on that as the radius of curvature r, right? So now consider angles alpha, beta and gamma, right? So from the geometry in triangle, so considering the triangle MOC, right? So triangle MOC, right? So exterior angle is equals to sum of opposite interior angle, right? So first we consider one triangle, so that is the triangle MO and C. So here the exterior angle is angle of incidence, so sum of the opposite, so ಈ angle ಗೆ opposite angles ಯಾವುದಿದೆ ಅಂದ್ರೆ r ಮತ್ತೆ alpha ಮತ್ತೆ gamma, right? So this is again from the geometry. So ಇದು ನಾವು basics, that is from 8th to 9th standard ಅಲ್ಲಿ study ಮಾಡಿರ್ತೀರಾ, right? So exterior angle is equals to sum of the opposite interior angle. So exterior angle is I, that is equals to sum of opposite interior angles. So opposite interior angles are alpha and gamma, that is alpha plus gamma, right? So next, similarly considering in triangle, so consider one more triangle, that is MCI or MIC, right? Triangle MIC. So again, by using the same statement, exterior angle is equals to sum of the opposite interior angle. So here the exterior angle is gamma, right? So opposite to this angle is r and beta. So exterior angle is gamma, that is equals to sum of opposite angles, that is r plus beta, right? So in this triangle gamma, that is equals to r plus beta. So we need r, so r is equals to gamma minus beta, right? So call this equation 1, equation 2, right? So now from Snell's law of refraction, so Snell's law of refraction, sine of an angle of incidence to the sine of angle of refraction is always constant. So that constant we taken as the refractive index. So N2 represents refractive index of the second medium with respect to the first medium. So refractive index of the second medium with respect to first medium, we taken that one N2 by N1, right? So here for small angles, so why we are considering small angles means, so the object distance is at a very large distance compared to that of the refracting surface. So if refracting surface is the object tumba ದೂರದಲ್ಲಿ ಇದ್ದಾಗ it behaves very small. So small means it almost ಈ angle ಏನಿರುತ್ತೆ ತುಂಬಾ ಚಿಕ್ಕದಿರುತ್ತೆ. So alpha ಚಿಕ್ಕದಿರುತ್ತೆ, alpha ಇದೆ ಚಿಕ್ಕದಿದೆ ಅಂದ್ರೆ I, gamma, beta, r ಎಲ್ಲ angles ಕೂಡ ಏನಾಗುತ್ತೆ ನಮಗೆ ಚಿಕ್ಕದಾಗುತ್ತೆ, right? So for small angles, sin I is approximately equals to I, sin R is approximately equals to R. So in case now only idu ellige applicable agutte ಅಂದ್ರೆ only in case of sin and tan. So iveradರಲ್ಲಿ ಮಾತ್ರ ನಮಗೆ direct ಆಗಿ sin of an angle is equals to that angle ಆಗುತ್ತೆ, right? So this becomes I by R is equals to into by N1. So N1 I is equals to into R. So from 1 and 2 we have the values of I and R, so substitute there, we get N1 into alpha plus gamma, that is equals to into gamma minus beta, right? So call this as third relation, right? So again, from triangle OMN tan alpha, so small angle is considered not that angle is approximately equals to alpha, that is equals to, so tan alpha is inside is ON, right? ON, right? So similarly, from triangle IMN, tan beta that is equals to beta that is equals to opposite side by MN, and the adjacent side is N, right? So again from triangle CMN gamma that is equals to MN by NC, right? So from triangles MON, CMN and N, right? So again from the trigonometry, tan alpha is equals to opposite side by adjacent side. So tan gamma is equals to opposite side by adjacent side. Tan beta is equals to opposite side by adjacent side. So now we need to substitute these values alpha, beta, gamma in equation 3, right? So that is N1 into, so alpha is Mn by On plus gamma is Mn by Nc, that is equals to N2 into, so gamma is Mn by Nc minus beta is Mn by Ni, right? So if you observe, in both LHS and RHS, in the numerator we have the common term, that is Mn. So ಇದಿಷ್ಟು ನಾವು ಕಾಮನ್ ತೆಗೆದು ಡಿವೈಡ್ ಮಾಡಬಹುದು, otherwise we can cancel here only. Mn LHS ಅಲ್ಲಿ ಎರಡು Mn ಕಾಮನ್ ತೆಗೆದು ಮತ್ತೆ RHS ಅಲ್ಲಿ ಎರಡು ಕಡೆ Mn ಕಾಮನ್ ತೆಗೆದ್ರೆ ಸೊ ಎರಡು ಟರ್ಮ್ಸ್ ಏನಾಗುತ್ತೆ ನಮಗೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. So only the remaining terms, so multiply ಮಾಡಿ within the bracket, that is N1 by On plus N2 by Nc, that is equals to N2 by Nc, that is minus N2 by Ni, right? So minus term na LHS shift ಮಾಡಿ, so common terms ಯಾವುದಿದೆ, so Nc ಮತ್ತೆ Nc ಎರಡು ಕಾಮನ್ ಇದೆ, so shift N2 to the RHS, right? So it is N1, right? So N2 left side shift ಮಾಡಿದ್ರೆ N1 by On plus N2 by Ni, that is equals to N2 minus N1 divided by Nc, right? So this is one more important relation. So ಈ relation ತುಂಬಾ important. By using this relation we are going to derive the another relation, that is length maker's formula. So ಈ relation ಇಟ್ಕೊಂಡು ನಾವು ಏನು derive ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, length maker's formula ನ derive ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, right? So what it indicates means N1, so refractive index of the first medium divided by ON. So this is the object distance. So first refracting surface ಯಾವ medium ಅಲ್ಲಿ ಇರುತ್ತೋ, so object ಕೂಡ ಅದೇ medium ಅಲ್ಲಿ ಇರುತ್ತೆ, so that we take on the object distance plus N2 is the refractive index of the second medium and Ni is the image distance in that medium. So second medium ಅಲ್ಲಿ ನಮಗೆ image form ಆಗ್ತಿದೆ, so that is the ratio of the refractive index to the object distance plus refractive index of the second medium to the image distance, right? That is equals to N2 minus N1 divided by Nc. So Nc is nothing but the radius of curvature. So ಇದನ್ನ ಎಲ್ಲರೂ ಬರ್ಕೊಂಡ್ರೆ N1 by object distance plus N2 by image distance, that is equals to N2 minus N1 divided by radius of curvature, right? So that helps to derive the next relation, that is length maker's formula, right? So next, if this object is at infinity, so ಈ object infinity ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ then the image is formed at the focus. So ಈ image ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ focus ಮೇಲೆ ಫಾರ್ಮ್ ಆಗ್ತಾ ಇದೆ, right? So by considering that case, right? So if object is at infinity, so object is at infinity means the distance O that is equals to infinity, right? So OP that is equals to infinity, right? So object is at infinity, then image that is pi that will forms at the focus. So that is again from the relations. So now lens alli discuss ಮಾಡಬೇಕಾದ್ರೆ ಕೇಸಸ್ ನ ಡಿಸ್ಕಸ್ ಮಾಡಿರ್ತೀವಿ. ಇಮೇಜ್ ಫಾರ್ಮೇಶನ್, ಸೊ ಇಮೇಜ್ ಫಾರ್ಮೇಶನ್ ಪ್ಯಾರಲಲ್ ಆಗಿ ಬಂದು ರಿಫ್ರಾಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಬೀಳ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ದೆನ್ ದ ಇಮೇಜ್ ಇಸ್ ಆಲ್ವೇಸ್ ಫಾರ್ಮ್ಡ್ ಅಟ್ ಫೋಕಸ್. ಸೊ ಇನ್ಸಿಡೆಂಟ್ ರೇಸ್ ಎಲ್ಲೋದು ಪ್ಯಾರಲಲ್ ಇತ್ತು ಅಂದ್ರೆ ದಟ್ ಮೀನ್ಸ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಇಸ್ ಅಟ್ ಆಬ್ಜೆಕ್ಟ್ ಎಲ್ಲಿ ಇರುತ್ತೆ ನಮಗೆ ಇನ್ಫಿನಿಟಿ ಇಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಇನ್ಫಿನಿಟಿ ಅಲ್ಲಿ ಇದ್ರೆ ಇಮೇಜ್ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ? ಸೊ ದಟ್ ಇಸ್ pi is equals to f. ಸೊ ದಟ್ ಇಸ್ ಫೋಕಲ್ ಲೆಂತ್. ಸೊ ಇಮೇಜ್ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತಿರುತ್ತೆ? ಫೋಕಸ್ ಫಾರ್ಮ್ ಆಗ್ತಿರುತ್ತೆ. ಅದು ಡಿಸ್ಟೆನ್ಸ್ ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಫೋಕಲ್ ಲೆಂತ್ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ಕನ್ಸಿಡರಿಂಗ್ ಫಾರ್ ದ ಸ್ಮಾಲ್ ಆಂಗಲ್ಸ್, ಸೊ ತುಂಬಾ ಸ್ಮಾಲ್ ಆಂಗಲ್ಸ್ ಇರೋದ್ರಿಂದ ದಿಸ್ ಡಿಸ್ಟೆನ್ಸ್ p is almost equals to n. ಸೊ wherever n we need to substitute p, right? So ಎರಡು ಕೂಡ ತುಂಬಾ ಚಿಕ್ಕದಿರುತ್ತೆ. ಸೊ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ p ಮತ್ತೆ n ವ್ಯಾಲ್ಯೂ ಏನಿರುತ್ತೆ? ಆಲ್ಮೋಸ್ಟ್ ಸೇಮ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ n1 by ON. So ON is nothing but OP, right? So that is the distance is how much? Infinity. So substituting n1 by infinity plus n2 by ni. So n1 infinity ಅಲ್ಲಿ ಇತ್ತು, ಸಾರಿ ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಇನ್ಫಿನಿಟಿ ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ಇಮೇಜ್ ಡಿಸ್ಟೆನ್ಸ್ ಎಲ್ಲಿ ಇರುತ್ತೆ? ಫೋಕಲ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, right? That is equals to n2 minus n1 divided by nc. So nc is the radius of curvature. So from the sign convention, so distance measure ಮಾಡ್ತಾ ಇರೋದು ಮತ್ತೆ ಇನ್ಸಿಡೆಂಟ್ ರೇ ಎರಡು ಕೂಡ in the same direction ಅಲ್ಲಿ ಇದೆ. So radius of curvature ನ ನಾವು ಏನು ತಗೊಂತೀವಿ? r ಅಂತ ತಗೊಂತೀವಿ, right? So that is r. Here we can write pc that is equals to r, right? So 1 by infinity 0, so this term becomes 0, right? So n2 by f that is equals to n2 minus n1. So this will further the next relation over, right? Lens makers formula. So we need to find the relation nu, v and r, right? So here by using sign convention. So here only directly by using sign convention, ON is equals to minus u, ni is equals to v, and nc is equals to r. Why minus? Because so incident ray e direction ಅಲ್ಲಿ ಇದೆ, but ನಾವು ಮೆಜರ್ ಮಾಡ್ತಾ ಇರೋ ಡಿಸ್ಟೆನ್ಸ್ ಪೋಲ್ ಇಂದ ಇರುತ್ತೆ. ಸೊ ನಾವು ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೆಜರ್ ಮಾಡ್ತಾ ಇದ್ವಿ, ಸೊ ಹೆನ್ಸ್ ವಿ ಟೇಕ್ ದ ಮೈನಸ್. ಸೊ ದಟ್ ಈಸ್ ಅಗೇನ್ ಫ್ರಮ್ ದ ಸೈನ್ ಕನ್ವೆನ್ಷನ್. ಸೊ ಸೈನ್ ಕನ್ವೆನ್ಷನ್ಸ್ ನಾವು ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿರೋದ್ರಿಂದ n1 divided by minus u plus n2 divided by v that is equals to n2 minus n1 divided by r. So finally we can write this relation n2 by v minus n1 by u that is equals to n2 minus n1 by r. So this one is the final expression, that is the relation between n, u and r. So n ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ n1 ಮತ್ತೆ n2 ಎರಡು ಬರುತ್ತೆ. So that is the relation. So small, so mathematical steps ತುಂಬಾ ಇದೆ, but diagram ತುಂಬಾ important. So diagram ನೀವು ಇದರಲ್ಲಿ ಒಂದು ರೇ ಡಯಾಗ್ರಾಮ್ ಆರೋ ಮಾರ್ಕ್ ಮಿಸ್ ಮಾಡಿದ್ರು ಕೂಡ ಇದು ವ್ಯಾಲಿಡ್ ಇರೋದಿಲ್ಲ, ರೈಟ್? ಸೊ ಯು ನೀಡ್ ಟು ಮೆನ್ಷನ್ ಆಲ್ ದೀಸ್. ಸೊ ಆಂಗಲ್ಸ್ ಆಲ್ಫಾ, ಬೀಟಾ, ಗಾಮಾ, ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಐ, ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಆರ್. ಸೊ ಮೊನ್ನೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿದ್ರೆ ಐ ಬರ್ದಿಲ್ಲ, ಆರ್ ಬರ್ದಿಲ್ಲ, ಓನ್ಲಿ ಕೆಲವರಂತೂ ಡಯಾಗ್ರಾಮ್ ನೇ ಬರ್ದಿಲ್ಲ, ಬ್ಲೈಂಡ್ ಆಗಿ ಇದನ್ನ ಬರ್ಕೊಂಡು ಹೋಗಿದ್ದೀರಾ. ಸೊ ಬ್ಲೈಂಡ್ ಆಗಿ ಇದನ್ನ ಬರೆಯೋದಕ್ಕೂ ಆಗೋದಿಲ್ಲ. ಸೊ ಈ ಡಯಾಗ್ರಾಮ್ ನೋಡೇನೆ ಇದನ್ನ ಬರೆಯೋದಕ್ಕಾಗುತ್ತೆ, ರೈಟ್? ಸೊ ಇಫ್ ಇನ್ ಕೇಸ್ ಇಲ್ಲಿ ನೀವು ಎಂ ಎನ್ ತಗೊಂಡೋಗೋದು ಪಿ ಕ್ಯೂ ಅಂತ ತಗೊಂಡಿದ್ರಿ ಅಂದ್ರೆ ಅಗೇನ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನಮಗೆ ಮತ್ತೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ಟ್ರಯಾಂಗಲ್ಸ್ ಅಲ್ಲಿ ನೇಮ್ಸ್ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಯಾವುದೋ ಬೇರೆ ನೇಮ್ ಇದ್ದು ಇಲ್ಲಿ ಯಾವುದೋ ಬೇರೆ ಡಾಟಾ ಬರುತ್ತೆ, ಅದು ವ್ಯಾಲಿಡ್ ಇರೋದಿಲ್ಲ. ಸೊ ಅಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಏನ್ ಮೆನ್ಷನ್ ಆಗಿರುತ್ತೆ ಅದನ್ನ ಇಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬೇಕು, ರೈಟ್? So move on to the next question, derived lens makers formula. So next, second question, lens makers formula. So ಇದರಲ್ಲಿ ಲೆನ್ಸ್ ಫಾರ್ಮುಲಾ ಇದೆ, ಲೆನ್ಸ್ ಮೇಕರ್ಸ್ ಫಾರ್ಮುಲಾ ಇದೆ, ಎರಡು ಡಿಫರೆಂಟ್ ಇದೆ, ರೈಟ್? ಸೊ ನೀವು ಕ್ವಶನ್ ಓದ್ಬೇಕಾದ್ರೆ ಕ್ಲೀನ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಲೆನ್ಸ್ ಮೇಕರ್ಸ್ ಫಾರ್ಮುಲಾ ಡಿರೈವ್ ಮಾಡಕ್ ಹೇಳಿದಾರ, ಲೆನ್ಸ್ ಫಾರ್ಮುಲಾ ಡಿರೈವ್ ಮಾಡಕ್ ಹೇಳಿದಾರ, ರೈಟ್? ಸೊ ಫಾರ್ ದಟ್ ಕನ್ಸಿಡರ್ ಒನ್ ಡಬಲ್ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್, so which having the refractive index n2, so the another medium refractive index n1, right? So again here also say, first draw the principal axis. So consider the object at a distance u from the center of the lens, so that we call as the optic center. So center of the lens na navena kariತೀವಿ optic center ಅಂತ ಕರಿತೀವಿ, right? So object A ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. So here also consider two rays which incident on the lens. So one is along the principal axis and another one is obliquely, right? So after it incident, it gets refracted and meets at the another point. So that is the image I. So here also refractive index n1, right? So image distance we taken v. So consider the lens of refracting surface. So double convex lens irodrinda idಕ್ಕೆ ಎರಡು refracting surface irutte. One is the first refracting surface is ABC and the another refracting surface is ADC. So here the image formation we will discuss in two steps. So ಇಲ್ಲಿ ನಾವು ಎರಡು ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. One is the first refracting surface ABC. So first refracting surface ಅಲ್ಲಿ image will form ಆಗುತ್ತೆ. Then the second refractive surface ಮೇಲೆ image L form ಆಗುತ್ತೆ, right? So image formation, we will discuss the image formation in two steps. So one is for the first refracting surface, second refracting surface, right? So first refracting surface, that is A, B, C. So first refracting surface ಏನಿದೆ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿರೋ ABC. So same object na consider ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ವಿ O. So from here the ray of light incident on the first refracting surface. So previous diagram ಅಲ್ಲಿ ಯಾವ ತರ ಇತ್ತು ಅದೇ ತರ ನಮಗೆ ಇಲ್ಲಿ image form ಆಗುತ್ತೆ, right? I1, right? So draw the normal. So that normal is passing through the center of curvature, we call that one C1, right? So for that, the first refracting surface, ABC forms the image I1, right? So first refracting surface ಅಲ್ಲಿ image form ಆಗ್ತದೆ of the object O, right? So object na ನಾವು O ಅಂತ consider ಮಾಡ್ತೀವಿ, right? So image is formed by the first refracting surface. ಆ image na ನಾವೇನಂತ ಕರೀತೀವಿ I1. So I1 is the image for the object O, right? So again by using the relation NUV and R, right? So N1 by object distance plus N2 by image distance, that is equals to N2 minus N1 divided by radius of curvature. Now apply here, right? So here the refractive index is N1, so here the refractive index is N2, that is inside the lens. So ಈ lens ಅಲ್ಲಿ ಏನಿದೆ ಅದನ್ನ ನಾವಿಲ್ಲಿ diagram ಅಲ್ಲಿ represent ಮಾಡ್ಕೊಂಡಿರೋದು. So this refracting surface having a medium of refractive index N2, right? So N1 divided by object distance, that is OB, plus N2 divided by image distance, bi1 that is equals to into minus n1 divided by bc1 that is the radius of curvature, right? So radius of curvature yavudu ಇಲ್ಲಿ ನಮಗೆ bc1, right? So next, this is for the first refracting surface. Now consider for the second refracting surface, right? So a DC. For the second refracting surface, the image I1 acts as a virtual object for the second refracting surface. So second refracting surface ke namge an image formed by the first surface irukko, so that will act as the object. So that object we call as a virtual object. So I1 acts as a virtual object for the second refracting surface, right? So here the refractive index is n2 and outside the refractive index is n1, right? So object is namage I1 is the object, so which incident on the second refracting surface, so hence the image is formed, final image is formed at I. So here by drawing the normal perpendicular, so that will meet at the center of curvature, so that we taken C2, right? So I1 acts as virtual object for the second refracting surface, acts as the virtual object for the second refracting surface. So e refracting surface ke I1 namge image in form ಆಗಿರುತ್ತೋ first refracting surface that is within inside the lens, so that acts as an object. So I acts as the image. So I ಯಾವ ತರ act ಆಗುತ್ತೆ ನಮಗೆ final image ಆಗಿ act ಆಗುತ್ತೆ, right? So I1 acts as a virtual object for the second refracting surface, right? So again by using the same relation, n1 divided by object distance into divided by image distance, that is equals to into minus n1 divided by radius of curvature, right? So here n1 by object distance, so object distance illiga namage second refractive index, so e medium alli namage object ide, right? So that's why n2 divided by object distance, right? So that is n2 divided by object distance we taken minus. Why? Because the incident light is from left to right, so here the object will form from right to left, right? So hence we taken that value, that is minus into divided by di1 plus n1 divided by image distance, that is di, that is equals to into minus n1 divided by dc2. That is the second relation. So ಇಲ್ಲಿ minus ಬರುತ್ತೆ, ಏನಕ್ಕೆ minus ಅಂದ್ರೆ towards right side ಇದೆ, so ನಾವು ಇಲ್ಲಿ incident light towards opposite ಇರೋದ್ರಿಂದ that's why we taken minus, right? So for thin lens, so thin lens means the thickness of the lens is very small, so ಈ thickness ಏನಿರುತ್ತೆ ನಮಗೆ ತುಂಬಾ ಚಿಕ್ಕದಿರುತ್ತೆ, so hence the point B is approximately equals to D, so adu ಒಂದು plane surface ತರ ಕಾಣುತ್ತೆ, so hence the distance BD1, BI1 is approximately equals to DI1, right? So why? Because B ಮತ್ತೆ D ಎರಡು almost same ಇರುತ್ತೆ, so B ಇಂದ ಮೆಜರ್ ಮಾಡಿದ್ರು ಅಷ್ಟೇ ಡಿಸ್ಟೆನ್ಸ್ ಬರುತ್ತೆ, D ಇಂದ ಮೆಜರ್ ಮಾಡಿದ್ರು ಅಷ್ಟೇ ಡಿಸ್ಟೆನ್ಸ್ ಬರುತ್ತೆ, so hence BI1 is approximately equals to DI1, right? So add equation 1 and 2, add equation 1 and 2, so LHS all add ಮಾಡಿ RHS, right? So N1 by OB plus N2 by BI1 minus N2 by DI1 plus N1 by BI, that is equals to, so ಎರಡರಲ್ಲೂ ಕಾಮನ್ ಟರ್ಮ್ಸ್ ಏನಿದೆ ನಮಗೆ N2 minus N1, so remaining is 1 by BC1 plus 1 by DC, right? So BI1 is approximately equals to DI1, so hence N2 by BI1, N2 by DI1 ಎರಡು ಏನಾಗುತ್ತೆ ನಮಗೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಸೊ ಮತ್ತೆ ನೀವು ಫರ್ದರ್ ಇನ್ನೊಂದು ಸ್ಟೆಪ್ ಬರೆಯಕ್ಕೆ ಹೋಗ್ಬೇಡಿ, ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ಬರ್ದಿರ್ತೀರಾ, ಸೊ ಇಲ್ಲಿ ಮತ್ತೆ ಚೇಂಜ್ ಮಾಡಿ ಮತ್ತೆ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದ್ರೆ ಮತ್ತೆ ಸ್ಟೆಪ್ಸ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ರೈಟ್? So the final relation we get N1 by OB plus N1 by DI, that is equals to N2 minus N1 into 1 by BC1 plus 1 by BC2, right? So here now the image is at infinity. So sorry, the object is at infinity, right? So if object is at infinity, image is formed at focus, right? So hence n1 by infinity plus n1 by f, that is equals to n2 minus divided by 1 by bc1, that is r1 minus 1 by r2, right? So this becomes 0, right? So 1 by f is equals to into 1 minus 1 into 1 by r1 minus 1 by r2. So this is the lens maker's formula, right? So remaining we will next discuss in our next class.